Hi everyone, once again we're working on transformations, and this is another where we're not given function notation and a graph already shown to us. We are looking at an equation and we're trying to pick out a parent function and transformations. So remember that transformations are always very simple operations. We're adding, subtracting, multiplying, or dividing, and we can figure out what that does to our graph. So anything that's not one of those operations is a pretty good candidate for your parent function. In this case, it is an absolute value. So we are imagining that we're starting with y equals the absolute value of x. So once again, you can sketch that in if you would like to, or draw it off to the side so that you have a reference. This time I'm seeing 4 out in front of the absolute values, so that will be a vertical stretch by 4. A +1 inside the absolute value, so that's affecting my x value. That will be a shift, but it will be the opposite. You won't add 1 to your x's, you'll actually subtract 1, so it will shift to the left 1. And then last step is a +3 outside of the absolute value. So that's adding 3 to our y's, and it really will do that. So the graph will shift up 1. Okay, so vertical stretch, I'm going to do that one on its own. Shifting should be last. This time I'm going to go ahead and do the shifting together. I'm going to do them both at the same time. And I already see that I wrote shift up 1 and it's really shift up 3. So let's fix that. Okay, so the vertical stretch by 4, if we look at the point 0, 0, when we multiply our y by 4, we're still at the point 0, 0. So remember, stretch or compression is always away from the axis. So you're going to pick up anything above the axis and stretch it even taller. Anything below the axis is going to stretch further down. Horizontally, it would be to the left and the right. So if we pick another point, let's say we pick the point 1, 1, it will actually move. When we multiply our y by 4, it will end up at 1, 4. So normally I would try and pick a point that wasn't all ones. So I'd avoid -1, 1 and go for -2, 2. But I actually think I might avoid that suggestion this time, because if I take the point -2, 2, it's going to end up at -2, 8, and that's a ways off my grid, so -2, 8. So I will actually take -1, 1 this time, and I think I'll still get a decent enough representation. So -1, 1, when I multiply my y's by 4, ends up at -1, 4. So we have this really tall, skinny version. And again, you can notice that multiplying your y's by 4 multiplies your slope by 4. So now the slope's ±4 instead of ±1. From here, I need to shift left 1 and up 3, which is totally going to run me off of my grid. And that's okay, we'll just plot the points. It happens sometimes. All right, left 1, up 3. So if I start with the corner at 0, 0 and go left 1, up 3, I will end up at -1, 3. If I pick up this left point at -1, 4 and go over 1, up 3, it will end up at -2, 7, which again off the grid, but we'll try and do a good job and we'll label that carefully to make sure that it's clear. And then the right point is at 1, 4. So if we go left 1, up 3, it ends up at 0, 7. So those are our points, and we're still expecting to see the shape of this parent function. So we will expect a right side up V that's pretty darn tall and steep looking. So that is my final graph for this one. Thanks for watching.